You can have the most amazing soundscape for a game, but it's irrelevant if it won't fit into the memory of the end user's game system. Wwise provides powerful features that allow you to maximize the use of memory when you integrate sound into your game without sacrificing its creative or sonic integrity. Let's look at how we can scale a project to work within memory budgets. Many video games are based on levels, and oftentimes there are sounds that are only associated with particular levels. In this build of the Cube demo game, the majority of the events listed here in the event viewer are used throughout all of the levels of the game. However, these events towards the top that begin with DCP, these are events that only occur in one particular map called DCP the core. It makes sense to only load the sounds associated with these events when the map they relate to is loaded. To do this, we can divide our audio across multiple sound banks, and then the game can be coded to only load the sound banks that are necessary for where the player is at in the game. To build sound banks, we'll use the sound bank layout. Let's go to Layouts and then choose Sound Bank. Now, the project currently does not have any sound banks, so we'll need to create them. Click the New button, and then we'll create the first sound bank and name it Main, for the main sounds used in the game. We'll create another sound bank, and this one will be called DCP underscore the underscore core. And this is for the unique sounds that only happen when the DCP the core map is loaded. Note that the names of the sound banks must perfectly match the names agreed upon in the game code. Each sound bank has columns that are related to data size. Currently, the data size says 0 bytes because nothing's been assigned to the sound banks. There's also a max size column where we can assign a value expressed in bytes to designate what memory budget is expected for the sound bank. Let's say in our situation that the budget for the main sound bank is 9 million bytes. So we'll enter that value. And the budget for DCP the core will be 6 million bytes, or 6 megabytes. Now, we need to populate these sound banks with their related events. So we'll start with the DCP the core. We'll select all the DCP events, drag them into the DCP the core sound bank, and then all the remaining events we will select and drag into the main sound bank. Now, go ahead and select both sound banks. Make sure that a platform and the appropriate language set is selected, and then click the Generate button. A progress window appears as the sound banks are generated. However, if we look in the results area, we can see that it indicates that neither sound bank was created. This is because they both exceeded the maximum size that we allowed. So the problem is that we know that we're not likely to hit our memory budget at first, but we still need to be able to generate the sound bank for testing and to get a sense for how much memory we're going to use. So we'll close this window, then go to the project settings, choose project settings, and then we'll click sound banks. And there's an option to allow sound banks to exceed maximum size. We'll click OK, and then click Generate again. The progress window completes, and if we close it, we can see that our data sizes appear in red. This is because we've exceeded our memory budgets for both sound banks, so we'll need to come up with some strategies to get under budget. There are various approaches to reducing memory usage, and one of the most effective is to convert the WAV audio files that were initially imported into another form that takes less space. This can be done by reducing the sample rate, reducing the number of channels, or even converting to another file type altogether. Wwise provides all of these options in the form of conversion settings. While it's possible to convert files one at a time, it's more common to apply conversion settings in bulk using what's known as a conversion settings Shareset. First, let's switch to the designer layout. Then, select the Sharesets tab in the Project Explorer. Now, in the Conversion Settings folder, select the default work unit, and then click the Create New Conversion Settings icon. Now, the bulk of our sounds consist of general sound effects, so we'll use this share set for conversion settings that generally apply to these types of sounds. So we'll name this share set SFX. Now that we have a conversion settings share set for our project, we can assign it to the objects in our project hierarchy. Select the Audio tab in the Project Explorer. Now, the assignment of conversion settings, share sets, just like any other object properties, are inherited from the parent to the child, so we only need to apply it to the top-level actor mixers. We'll start by assigning the share set to the weapons actor mixer. Now, in the Property Editor, click the Source Settings tab. Go to the Selector menu and choose the SFX share set you created earlier. Now that we've assigned a conversion settings share set, we now need to adjust the conversion properties of this share set. So, in the conversion settings area, click the Edit button. The conversion settings editor opens, and the upper part of the window shows conversion properties that are applied to any objects assigned to this share set. The lower part shows a list of all the objects that are currently assigned to this share set, along with details including the original file size. Now, there are a variety of conversion processes that can be applied to an audio file to help reduce its size, but Vorbis data compression typically does a good job of reducing the file size without sacrificing too much sound quality, so we'll go with that to start. In the Format column, change the value from PCM to Vorbis. The audio sources turn blue, indicating that they have yet to be converted to our newly selected conversion setting. A quality property value, which is a specific value for the Vorbis option, is displayed with a value of 4. A value of 4 is a good starting point because it dramatically reduces file size while providing acceptable sound quality in most situations. Now, click the Convert button to apply our conversion settings. Select the appropriate platform, and then click OK. A conversion progress window is applied. Now, after a brief bit of processing, the audio file names in the file list change to white, and this indicates that they've all been converted. And we can now see that the converted file size has been reduced dramatically, in most cases from about 70 to 80%, which is a huge savings in space. We can compare our sounds before and after conversion at any time. Just select a sound, and in the transport, click play. Now notice that the original button is selected. This indicates that we're hearing the original unconverted sound. To compare after the conversion, just deselect the original button. Now we've heard the converted version, which sounds nearly identical. Close the conversion settings editor. In some cases, compressing files may simply not be enough to get the memory footprint low enough, and we may need to remove certain audio elements from the game altogether. In cases where we've used multiple audio files, for example in a random container, we may find that removing a few from the pool of sounds may not be that noticeable and help us get us under our memory budget. Rather than deleting the objects, we can simply exclude them from the build of the SoundBank. Let's look, for example, at the main character, and within it, there is a jump and a pane random container. Now, we can deselect platform inclusion checkboxes for some of these Sound SFX objects, which removes them from the build of the SoundBank. But the nice thing is, it won't delete them, and so we can always add them back later if we choose. In this case, we'll take off maybe about half of these panes, and a couple of the jumps. Another way to reduce memory is to not load the entire audio file into the game system's RAM all at one time. Instead, streaming provides a way in which the audio can be played directly from the stored memory, such as an optical disc or hard drive. The downside of streaming is that when the game engine calls for the sound, there may be a pause before the sound starts to play. This wouldn't work for a gunshot, but it's typically fine for things like music or long ambient beds produced from a single audio file. This is the case with the Cube main theme that's being triggered from the DCP the core sound bank, which is drastically over its memory budget. Let's take a look at it. Here's the Cube main theme, and if we play it, it's this kind of longer ambient bed, and it's perfect for streaming. In the Property Editor, click the General Settings tab, and then we can click the Stream checkbox. Now, other streaming properties now appear, but it's not necessary to change these parameters unless we would want to minimize the delay in starting the stream, which isn't necessary in this case. To see the memory savings that we've acquired, let's go back to the sound bank layout and generate our sound banks. So we click Generate, click Close, and now we can see that the changes we've made have made a considerable amount of savings to our memory, and it's now put us under our memory budget.